is Wednesday, March 6th, and we are doing Module 4, Lesson 19. Okay, and your learning goal today says, I can use what I know about converting measurements to solve multi-step word problems. So today we're going to use what we've learned about multiplying fractions and apply them to how we might convert measurements. We've converted measurements before, but we're going to work on that again today. And they're going to help us eventually solve multi-step word problems. This morning you had a problem of the day that Miss Scott did with you. Some of you did not pay attention and did not follow along. It is important for you to start each day by writing down the date, the learning goal, and then for the problem of the day, there are 3 steps. Writing down what the question's asking, the important information, and then show how you know. As I was walking around the room, I saw that Rupa had a different way of solving the problem of the day than what Miss Scott did. So I'm going to invite her up to teach us what she did. Today we are working with unit conversions. Whenever we use unit conversions, we use the same format. So let's write that down really quickly in our notebook. Unit conversions. Write that word down. We always use the same format. This is the problem we're going to solve, but we're not going to do it yet. Okay, let's first talk about how we solve unit conversions. We always are given an, let's call it old unit, and we want to turn it into some sort of a new unit. Do you agree? Okay, we have some number of old new units, and we want to turn it into some number of new units. This is some number, right? So what we always do is we always follow the same format. We always do whatever the number is times 1 of the old units. Do you agree? And then what happens? We want to change it to the new unit, right? So it's some number of whatever the conversion is of the new, right? And what do we know? We know that the things inside the parentheses, this, needs to be equivalent to this, right? And that's what gets us to some number of the new units. Do you agree? We've done this before many times, right? Okay, so let's apply that. Thank you for your patience as I deal with my, oh my gosh, okay. Let's get this together. Conversions. There we go. Okay, so let's take a look. What is our old unit? No, what's the old unit? Feet. What's the new unit we're trying to get to? Okay, so if I start with some number of old units, and I want to get to some number of new units, right? So I have to follow this format. What's my original number? 6 feet times 1 of my old units. What's my old units? Foot. Okay, so that's this line right here, right? Do you guys agree that 6 feet equals 6 times 1 foot? Yeah, 6 copies of 1 foot is 6 feet. Very good. Now, I have to change it. That's equal to, oh, by the way, this should still be this number, huh? Okay, it's equal to 6 times 1 foot is the same as, I want my new unit. 1 foot is how much of a yard? Right? Because I have to think in my head, here is 1 yard. Is a foot bigger or smaller than 1 yard? Because it takes 3 feet to make 1 yard. So 1 foot is going to be equivalent to 1/3 of the yard. This is this step, where I have the same number, 6 times my conversion of my new units. You see that? Okay. And then now, I just multiply. 6 times 1 all over 3 yards. Do we have common factors? Yes. I can divide 6 times 1 all over 3 yards by what number? 3/3. Which is what number? 1, but what version of 1? Good, so 6 divided by 3 is? 2. 3 divided by 3 is? So this is equal to 2 times 1 all over 1 yard, or 2 yards. So therefore, 6 feet is equal to 2 yards. The most important thing you can do is write down for yourself these measurements over here, okay? Again, we're writing it both ways. We want to find out how many pints are in 1 quart. We also want to find out how many quarts are in 1 pint. The reason why we write it both ways is to help us avoid making silly mistakes when we do our conversions. Make sense? Okay. You got it. This question's asking us to find out how much money Marty had to pay. All right, Arnav, what's the important information?
He bought 12 ounces of granola.
Okay, he bought 12 ounces of the granola.
And 1 pound of granola cost $4.
1 pound of granola costs $4. Very good. So we need to first, pause. The problem tells us that Marty bought 12 ounces of granola. One might call that our old units, right? But the price is in pounds. So can I just charge him 4 times $12? That's not fair. It's $4 per pound, not $4 per ounce, right? If I did that, I'd probably charge him way too much money. So this is a multi-step problem. What is the first step we'll have to do? Christopher?
First step was we're going to have to convert ounces.
We have to convert 12 ounces to some number of pounds. What will step 2 be? What will step 2 be? Rashita? Then I'll have to multiply $4 by however many pounds there were to find out how much money. Okay, so let's do that. 12 ounces equals how many pounds? Well, the first thing we have to do is think about our old units versus our new units, right? So 12 ounces equals how many pounds? What's our old units? Ounces. What's our new units? Let's write out our thought bubble. Let's write out our conversions. How many conversions should we write out? 2. One's going to start with 1 pound equals how many ounces? And the next one's going to be 1 ounce equals how many pounds? Good. What's bigger, 1 pound or 1 ounce? So let's start with that one. 1 pound is equal to how many ounces? 16. So if I have 1 ounce, do I have a whole pound?
No.
Some might say I have a fraction of a pound. What fraction of a pound would I have? 1/16. Very good. Once you have your thought bubble with both conversions, we're ready to do our conversion. 12 ounces equals how many pounds? Well, that's the same thing as 12 copies of 1. Everyone, let's say it together. 12 copies of 1 ounce. That's the same thing as 12 copies. Now we want to convert it from ounces to pounds. 1 ounce is equal to how many pounds? 1/16 of a pound. We're in our new units now. We can multiply. 12 times 1/16 is 12 times 1 all over 16. I see that 12 and 16 are both divisible by? They are both divisible by 2, but they're also both divisible by? So we can divide 12 times 1 all over 16 by 4 over 4. 12 divided by 4 is? 16 divided by 4 is? My new multiplication problem is 3 times 1 all over 4, or 3/4. So therefore, we know that 12 ounces is the same thing as 3/4 of a pound. Is that the answer? 12 ounces equals 3/4 of a pound? No. That's the answer to step 1. If I look back at what the question's asking, how much did Marty pay? Well, he did not pay 3/4 of a pound. But he paid $4 for each pound. So how can I find out how much money he paid altogether? Elmer, what do I need to do?
3/4 times 4.
3/4 times 4. Luckily, we know how to do that. Yes? So for step 2, we have to do 3/4 of a pound, right, times $4. Okay? So that's 3/4 times 4, or 3 times 4, all over 4. What do you guys notice? 4 and 4 are both divisible by?
4.
Let's do that. Let's simplify. 4 divided by 4 is 1. 4 divided by 4, of course, is 1. So I have 3 times 1 all over 1, or 3. What should my units be? The question's asking how much did Marty pay? What are my units? Dollars. Very good. So this is an example of our learning goal. We used what we know about converting units to solve a multi-step word problem, a word problem that has more than one step.